Welcome to this module of Professor Messer's free CompTIA Network Plus certification training course, the online training course that gives you plus 15 to intellect. I'm James Messer, and in this module we're going to discuss the idea of subnet masks. This is part one of two where we're going to talk about subnet masks. It's a pretty broad topic, but it's one that's extremely important for IP networking, and one when you get into the networking technologies, you'll just use subnet masking every day, or some aspect of subnet masking every day. This comes from our Network Plus exam N10-004, section 1.4, where given a scenario, we need to evaluate the proper use of the following addressing technologies and addressing schemes. We're going to build on our previous module of binary math. So if you haven't seen that or you're not familiar with doing any type of binary math, we're going to skip over or just assume you know how to do that aspect of it. So if you're going through this module and you're wondering, how did we calculate that? You may want to go back and look at that previous video. Let's talk about why you would subnet the network. Why is this even necessary? Why is this on the exam? And why is it so difficult to get into our brains? Why we would need to subnet the network? Well, of course, our networks that we use today are extremely large and they are worldwide. You cannot have everybody in the world on the same network at the same time communicating. There's aspects of the fundamentals of being able to talk from one device to another that doesn't allow us all to sit on the same physical network. There's geographical boundaries, there's technological boundaries, in a lot of ways there are security type needs to be able to subnet the network into smaller pieces. We're going to look at aspects of this, but you'll notice that we're going to use a lot of IP addressing subnetting when we talk about doing this on our networks and how it's being used. And we need to really start with the fundamentals. In this module, we're just going to talk about the idea of subnet masks at the perspective of an individual workstation. Our next module is going to be about how we would take a single network and split it up into smaller pieces. So depending on where we're coming from, you may need to do different pieces with our subnet masks, but this video is a very good place to start because it's from the perspective of what you see when you're on the network and using a single workstation. Now, to do any subnetting, you need three different pieces. The first thing you need is an IP address. This is probably something you're very familiar with. We need to know what our IP address is. This is something you're either assigned automatically when you log or touch our networks, or perhaps it's something that's assigned to you by a third party. Your IP address is this number. Every device on an IP network needs a unique IP address. These can't be shared between systems. Only one station at a time can have a single address. If we are 192.168.1.165, nobody else and no other device on this network can be 192.168.1.165. The other thing that we'll need is the subnet mask. We're going to be talking a lot about subnet masks in this video. This is what our local workstation uses to figure out what subnet we happen to be on. All of these networks that we happen to have are split up into other pieces, and our single device needs to know, do I go out and talk to a router to talk to the rest of the internet, or are the people that I need to talk to on my local network? And depending on whether it's someone on your local network or someone on a remote network, will make a determination to your individual workstation who it happens to talk to and how it communicates to that device. So the subnet mask becomes very important. You're going to ask for the subnet mask all the time. Somebody will say, here's my IP address, and the question you'll have is, what's the subnet mask? You need that piece of information because it all is based on where you are in this network and what network your system thinks it happens to be on. The other third part that is important, and most times it's critical to being able to talk out to the rest of the network, is something called the default gateway. This is the router that is on our local network. So if we are 192.168.1.165, we may have a router or a default gateway on our network called 192.168.1.1. It is this router and that particular IP address that we will talk to if we need to talk outside of our local network. So extremely important. If this is a network that is not connected to anything else, it's not on the internet, there are no extra networks, you may not even have a default gateway. That's not usually the case, usually in most networks. So almost always you're going to have some type of default gateway. An important thing to keep in mind is the IP address of this default gateway has to be on your local subnet. If this IP address that you were given is on a different subnet, you won't be able to talk out to anything else. And sometimes you'll be given the wrong default gateway. Someone will give you an IP address and a subnet mask. An important task for us as Network Plus professionals is to know if they give you a default gateway, is that default gateway on our network or not? You can double check some of the information they're giving you based on the IP address and subnet mask they happen to give you to begin with. A little secret about IP addresses is they are not just a single address. There's a lot more to this IP address than meets the eye. This IP address is actually a combination of a network ID and a host ID. And it's all combined together into these decimal numbers that we are accustomed to seeing. But the subnet mask that we've been talking about is really what determines what part of that IP address is the network address and what part of that IP address is the host address that we happen to be running. So there are really two different things going on here. That single IP address really gives us a lot of information about our network number and the host number that we happen to be on that network. Those two things work together on an IP network so that you're able to then communicate to other devices out there. That's why that subnet mask is just as important as the IP address. You have to use those things in tandem. Now, the best way to see this work is in binary. We're going to be doing a lot of binary calculations, just additions that we're doing with our binary math. It's very simple. And again, if you aren't familiar with binary math, go back and look at our binary math module to see how that works. It's very fundamental in the way it works, very easy, but we're going to be using a lot of that in this module and a lot in the next modules that we're going to do. A term that you're going to hear a lot about is something called classful subnetting. This was the original subnetting methodology that was used on the internet, and it really hasn't been used since 1993, but you'll still hear it referred to at times when somebody's describing a subnet mask or a subnetting configuration they happen to have in their environment. There are three classes that we need to know about. There's actually five. I'll show you in the next slide. The three that we need to know about for subnetting is Class A, Class B, and Class C. For lack of a better name, but not very original, but it serves a purpose. Class A is a subnet mask called 255.0.0.0. Class B is 255.255.0.0, and Class C is 255.255.255.0. It used to be those were all the subnet masks that we would ever use on our networks. Now, we found out very early on during the boom of the internet that we're going to need a lot more than just those three classes of subnets. We're going to need to separate things out a little bit better. In fact, these are the ways that we had these subnets done. A, B, and C, I told you there was more. There's a Class D, which is used for multicast, and there's a Class E, which was something that is reserved. It's not really used in normal communication. Now, the way that we determined right off what class of a network we had was to look at the first 4 bits of the IP address that we were given. Now, if we don't know the first 4 bits, we can look at it in decimal too if we don't want to do the binary math. If your IP address starts with the number between 1 and 126, it was Class A. If it starts with the number between 128 and 191, it's a Class B. And if it starts with the number 192 to 223, it's a Class C. So it used to be we didn't even use subnet masks. We knew based on the first decimal octet of that IP address what class it was, automatically knew if it was a 192 address, then it was Class C, and we automatically assumed that it was a subnet mask of 255.255.255.0. The problem with this is that you have a certain number of networks that you can have for that Class C, which is about just over 2 million types of networks, 2 million different subnets that are out there. And on that network, there can be 254 hosts. Well, this became a bit of a problem if we needed more networks. Let's say that we needed, for our particular network, we were an organization that had a lot of networks, or maybe we needed some networks that had more than 254 hosts per network, then maybe we need a Class B. Well, the problem is that you get 16,000 networks with a Class B and 65,000 devices per network. And if you've worked at all with IP subnetting, that's a lot of devices on a single network. That really doesn't work that well anymore on a per network basis. There's no in-betweens there. Huge gaps between the number of networks and the host per networks between a Class A, a Class B, and a Class C. And this created some problems. First, it wasn't very scalable, and people were having huge chunks of IP addresses that were sitting unused, and we were finding that we were very quickly running out of IP addresses on the internet. So we came up with this idea of throw out the classes. We don't need the classes anymore. We're going to do something called classless subnetting. And this is referred to as classless interdomain routing, or CIDR. we refer to it as. In 1993 or thereabouts, we created this idea of forget restricting ourselves to a specific Class A, Class B, Class C. Let's just pick a number of bits that we would choose to be our subnet mask, and that's the number of bits that you'll get. And what we do is we put this slash notation, and then we put the number of bits associated with that. So instead of saying we're going to use a Class C address, we're going to use one that's a /24. It's exactly the same thing. In fact, you'll still hear people talk about a /24 as, oh, you have IP address 192.168.1.0 and it's a Class C. Well, it's not really a Class C, but it's exactly the same subnet masking as a Class C. It's a /24, it's a Class C, or it's a 255.255.255.0. There's 3 different ways to say exactly the same subnet mask. So don't be thrown by that. That's just normal conversational descriptions of how we describe how these subnet masks are. But notice that the boundaries aren't at these 255 numbers anymore. We could have a subnet mask that uses 26 bits. And if we converted that out into something that was decimal, that would represent 255.255.255.192. Well, this opened up a lot of different ideas for us. We could have a lot of different sized networks with a lot of different sized hosts on them. This is how a subnet mask looks whenever we spell it out, if you will. We take that decimal 255.255.255.0 and let's write it out into binary. This is where this binary math comes in. If we've been given 192.168.1.0 as our IP address and somebody said your subnet mask is 255.255.255.0, let's calculate out what this subnet is and how many people could be on this subnet. And what I've done here is take those same IP address and subnet mask and I've written it out in binary. And if you remember the tests that we did, the tasks we went through in our subnet masking and our binary math module, we really just take the 192, it converts into 11000000 in binary. And we just did that all the way down. I did the same thing with the subnet mask, 255, 255, 255, 0, which is all ones, all ones, all ones, and all zeros. Now, because this is a subnet mask, every time we see a 1 where the subnet is, that is the network we happen to be on. Every time there is a 0, those are the hosts that are available on that network. So let's do some calculations here. If we know that our network is what is masked, if you will, by the ones, and the client addresses are not masked by the ones, then we've got these 8 bits available. So that means we can have 254 possible client systems or devices on this particular subnet. And the reason it's 254, not 256, is because you take the total number of host bits available, and if we add all of that up, it all comes out to 0 to 255 or 256. We take 2 away from that. One of those addresses is going to be a subnet address. The other address is going to be a broadcast address. And you're going to do this every time you calculate what this subnet's about. You're going to calculate a subnet address, you're going to calculate the number of devices on the network, and you're going to calculate a broadcast address. So let's do that right now. Let's calculate out what our subnet happens to be. And let's calculate also out what our broadcast address happens to be for an IP address that we happen to know. And if you'd like, you can use the IP address that's on your system and perform exactly the same function that we're doing here. We're going to use the example 192.168.1.165 with subnet mask 255.255.255.0. Yours might be different, but whatever it is, already do your binary calculation and put both of those numbers down in binary on your screen. Now, I've also color-coded mine so that every place there's a subnet mask of 1, I've colored it in blue to designate that's my network address, and I've created this brown number here to designate those are my host bits, so I can visually see that on the screen. Now, to calculate our subnet address, what we need to do is something called a bitwise AND. Well, that sounds complicated, but it's actually very easy. What we're going to do is every place we see 2 ones together, we're going to bring down a 1. And every place we see a 0 and a 1, we'll bring down a 0. And if there's a case where we have 2 zeros, we bring down a 0, like we did over here. And if that's the case, when we put all of these together and perform that bitwise AND function, we get a subnet address. So if we recalculate this back into decimal, it's 192.168.1.0. That is the subnet. Somebody says, what's the subnet address for that IP network that you happen to be on? Oh, our subnet address is 192.168.1.0. Now, if somebody asks, what is the broadcast address for the network you happen to be on? All you have to do is take those same numbers you came up with, but instead of all zeros down here for the host available, change all of those zeros to a 1. And what you'll have is that same blue number there, the 192.168. Just bring down every blue number that you were given, but instead of all zeros for your host, put all ones down in those host addresses, those host bits that are available to us, and calculate that out. And if we do, it's 192.168.1.255. And there we go. Now we've got, on the network we happen to be on with our computer right now, our subnet address is 192.168.1.0, and our broadcast address is 192.168.1.255. And it's just that easy to calculate what the subnet mask, using the subnet mask, what our subnet address is and what our broadcast address is. If we summarize this out, there's our IP address and subnet mask, our subnet address and broadcast address. And we know, based on the number of bits that were available to us, those 8 bits, that we have 254 possible hosts on this network. And that should be pretty easy to calculate. It's the numbers that are between our subnet address and our broadcast address. And you can see here, we can calculate that out as 192.168.1.1 all the way through 192.168.1.254. Now, in our case, this was pretty easy to calculate because our subnet mask ended right there at that period. We had 8 bits to work with. It was very easy to understand in our minds relative to perhaps a subnet mask that used additional bits that were in there. So it might be useful to go through and calculate a few of these back and forth to see how it might work with other subnet masks or other IP addresses. Let's do another calculation then. Let's look at a situation where our IP address happens to be 10.11.12.13, and we know that our subnet mask is 255.255.0.0. One of the things I've also done is written down, here's how we would write this out in a CIDR block notation, we call it, where it's a 10.11.12.13 slash the number of bits that are available for your subnet mask. And if it's a 255.255.0.0, that means it's a slash 16. And we can visually see that. If we were to take that 255.255.0.0 and write it all out in binary, we can see there are 16 ones right there, and that's where that 16 is coming from. So that's our first step. Take our IP address and our subnet mask, calculate it out in binary. And again, I've color-coded it just so you can see every place we have a subnet mask of 1, I've put it in blue, and every place there are zeros, I've made them brown colors here on the screen. And if we do our bitwise AND, in every place that there are 2 ones, we just bring a 1 down. Every other situation gets a 0. And then we calculate this back into decimal. We can see that our subnet address is 10.11.0.0. And if we happen to take all these zeros and turn them into ones, then we know that our broadcast address is 10.11.255.255. So we know the very important things to keep in mind on this network is our address 10.11.12.13 with subnet mask 255.255.0.0. In summary, we know that a subnet is our 10.11.0.0 and the broadcast address is 10.11.255.255. And if we were to write out in our decimal form what that happens to be, it would be 10.11.0.1 through 10.11.255.254. All we did was put a 1 down there in binary and then all ones there in binary and subtract 1 from it. And we've got our host address range on this particular subnet. That's a big subnet with 65,000 devices on it. You usually don't see a subnet quite that large in a normal environment, but there are some networks in the world that do have subnetting that's set up that way, even if they aren't planning to put 65,000 devices on the network. In this module, we've looked at doing subnet mask calculations from the perspective of a single device on the network, trying to figure out what is on this network with us. What other IP addresses can we expect to see on this subnet? What is our network address and what is our broadcast address? So let's see how well we remember some of these things. What is the default subnet mask of a Class C network? And if you remember our class-based networking, we had a Class A, a Class B, and a Class C. So what is our Class C subnet mask? If you recall, it's 255.255.255.0. If we were to write it out in our classless type of CIDR block notation, we could write it out as a /24. So if somebody says, oh, you have a Class C subnet here, that's what they're referring to as that subnet mask. Now let's say that we have an IP address of 192.168.1.204 and we have a subnet mask of 255.255.255.128, which means there are 25 bits in this subnet mask. And we need to know what's the range of addresses in this network. Now I'll give you a second. You can pause this and maybe calculate it out. But another thing that I'd like to do is walk you through how you might determine that, because you might get a question about what is the range of addresses on the subnet, or you might get a question on your exam, is this certain IP address also on your network if this happens to be your IP address and subnet mask? So let's do the calculation. We're going to do exactly the same thing we did before. We're going to take our IP address and our subnet mask and we're going to write them out in binary. And you can see here I've written out all of my 25 bits available in my subnet mask. Notice that our blue bits go all the way into that last octet. And what we're going to do the same thing we did before. We're going to perform our bitwise AND function. Every time there are ones, we're going to bring down the 1. Every time there's a 1 or 0, we bring down a 0. Every time there's a 0 or a 0, we bring down the 0. And you can see that what we come up with for a subnet address, if we recalculate this number back into decimal, our subnet address is 192.168.1.128. And what we'll do also again is take all of those zeros that we have here, turn them into ones, and calculate that also out in decimal. And it turns out our broadcast address is 192.168.1.255. So we know that our IP addresses that are on the subnets are all the IP addresses between those two numbers. Here's our summary then. Our IP address range is 192.168.1.129 through 192.168.1.254. And that's the answer to our question. That's the range of addresses in the subnet. And if somebody says, is the IP address 192.168.1.4 in your subnet? You can say no, because we know that 129 through 254 happens to be in our subnet, and 4 is in a completely different subnet than we're in. We would need to talk through a router if we wanted to communicate out to that subnet. And we're going to talk more about routing and those types of technologies in our routing section. But that's now how you're seeing all of these different pieces fitting together. That's why subnetting is so important. In summary, we've looked at this N10-004 requirement from Section 1.4, where we need to start learning about addressing technologies and subnetting and how we get some of those values out in our subnets. For the next part of our subnetting video, for many more Network Plus videos, our message boards, and much more, you can visit our website, freenetworkplus.com.